Okay, so we're doing 12.5, which is binomials. So we're going to start off with the binomial coefficient. There's going to be two ways to do this. So the first part starts out with the binomial coefficient, which is this. So you have for two non-negative integers and an r, okay, where r is less than or equal to n, you have them written like this, one on top of another, which means this. So n with the exclamation point, do you guys remember what that means? Anybody? Factorial. Okay, so that is n factorial over r factorial, n minus r factorial. And factorial means, does that word ring a bell or still no? Okay, so it means you're going to take the number, so 5 factorial, and you're going to multiply it, just going down each one. So 5 times 4, 3, 2 times 1. Okay, so 100 factorial, 100 times 99 times 98. Very, very, very large number. You can do factorial, and you can do this in your calculator. So first, the factorial is really simple to find in your calculator. So if I did 5 factorial, well, first of all, let's see what that is. It's 120, okay? But you can also do 5 factorial. So if you go 5 and then over to math, then over to PRB, it is number 4, the exclamation point. And then it will do it for you, 120. So if we use the formula here, okay, you have 6 would be your n, 2 would be your r for this example. So you would write it as 6 factorial over r factorial, so 2 factorial over 6 minus 2 factorial. Okay, which would then be 6 factorial over 2 factorial. 6 minus 2 is 4 factorial. You can work that out. You can go like this, 6, 5, 4, 3, 2, 1. And then 2 times 1 times 4 times 3 times 2 times 1. What ends up happening for these is these 4's cancel, these 3's cancel, these 2's cancel, and these 1's cancel. So 6 times 5 is 30. 2 times 1 is 2. So that's going to give you 15. Okay, so you could do it like that. Another way you could write this out, you might see it written like this if you looked at an example. Go back here to where it had 6 factorial. So 6 times 5 times 4 factorial over 2 times 1 times 4 factorial. And then just the factorials of the same number would also cancel. This is actually, in your calculator, the combination formula. Okay, so in your calc, it is NCR. Okay, so here for my calculator, we go 11 C4, so like 11 choose 4. So I would go here 11, and then math, and then over to PRB again. Now this time it should be this NPR, and then 4. Or sorry, NCR, not NPR. And then I'll give you 330. So notice there was an NPR. You want to be careful. This one is using the NCR. Now that I said that, I want to check and make sure. So I'm going to check the one we already did. Yeah, so this is using the NCR command. The difference between them, so C is combination, which means that the order isn't going to matter. And then P is permutation, so the order does matter. So that's the case. So an example for a combination would be like picking a committee. So out of 11 people, I'm picking a committee of 4 people. How many different ways can that committee be composed? An example of a permutation is where order matters. So in a race of 8 people, how many different ways can first, second, and third be combined? And then the way that I like to remember it is C, committee, P, placement. that helps you guys. But just for pre-calc, so that's more of a stats thing. But for pre-calc and CR for this binomial theorem. Okay, and then we can do these. So you have 8C0, so 8 math and CR 0. This is going to give you 1, because you're only picking committee of 0. There's only one way to do that. We pick nobody. Yes, sir.
You would actually use that formula where you have a 0 on the bottom and the end.
No, because that's a good question. Because there's a rule for factorials. In that 0 factorial is 1. So that's a good question, because typically, yes, if it was just a 0 on the bottom, but 0 factorial, which is going to equal 1. Yeah, it is the rule for factorials, because you're thinking of ways to choose things. So there's only one way to choose 0 things, which is to choose 0 things. If that helps. But yeah, 0 factorial is 1. So if you have the 0 on the bottom, then it's just basically 8 divided, or yeah, 0 divided by 1, because it works out like this. So these cancel, and you get 1 over, no, 0 over 1, which gives you 0. 1. It's 1. Why did I put 0 for the answer? It's 1 over 1. Now you got me confused. Yes, it's 1 over 1 gives you 1, not 1 over 0. Okay, and then the 17, did I answer your question okay?
Yeah.
Okay. All right, and then the 17 and 6, so 17 math, PRB, and CR 6. It's going to be 12,376. Okay, so you can, oh, why does it keep doing that? You can use the binomial theorem, or technical difficulty. Okay, so now we're looking at binomial expansion. So we've already done pretty much the first 3, even maybe the first 4. You guys can multiply that out. But it starts to get really painful when you go further than that with the multiplication. So this is actually revealing a pattern. So if you notice here, start with this. You have x to the first, y to the first, okay, when it's expanded to the first power. For the second power, okay, it's the first term to that power, last term to that power. Okay, the middle 2 terms, okay, this goes in descending order. This goes in ascending order, the y. Starts to be a little bit more apparent if you look down. So go down to the 5th one, you have x to the 5th, x to the 4th, x to the 3rd, x squared, x to the 1st, x is gone. Same with the y's. Y is gone, then 1, 2, 3, 4, 5. So it's revealing a pattern there. Okay, we're going to look at that pattern. And then also the numbers in front. So here's the pattern. Okay, the expansion begins with an x to the power that you're expanding and ends with y to that power. The variables follow this pattern where the x is going to descend and the y is going to ascend. Or the first term and second term. The exponents on the first term descend, the exponents on the second term ascend. The sum of the exponents is always going to be n. When we add them together, And the coefficients actually follow a pattern, and that pattern is going to be Pascal's triangle. So we're going to use Pascal's triangle to do our expansion, but I want to show you what the binomial theorem is first, because there's going to be two different ways to solve this. So I'm going to show you the first way, and then I'm going to show you with using Pascal's triangle. Okay, so for this one, for positive integer n, here is your formula. Okay, so this is the way the book is going to explain it. There is actually an easier way to do it. So I'm going to show you this in case you like it with this formula. So you're using the combination formula here, okay, and then you're putting the pattern with your terms. Okay, so you have a first term of x, second term of 5, and it's to the 6th power. Okay, so your n is going to be that 6 there. Get that off there. All right, so here's how we're going to set this up. So we're going to start with the x, and that's going to be to the 6th. Okay, then we're going to have n and 1, so it's going to be a 6, 1, and then it's x to the n minus 1, so it's x to the 6 minus 1, and then also your y term, which in this case the y is a 5. I'm going to put that in parentheses, 5. Okay, then plus 6 and 2, then we have an x to the n, so 6 minus 2, and the y term, which is 5, to the 2nd. Okay, then I'm going to leave some space so we can work underneath that. Then we have plus, we have our n, which is 6, and 3, then x to the 6 minus 3, and then our y, which is 5, I wrote y, to the 3rd. So we're going to do this till we get to 6. So then you're going to have a 6 and a 4, and an x to the 6 minus 4, 5 to the 4th. And then a 6 and a 5, x to the 6 minus 5, 5 to the 5th. And then finally, 6, 6. You know you're going to stop when you get to that integer. And then x to the 6 minus 6, 5 to the 6th. Yes. Okay, so then we want to work this out. So the x to the 6 is going to stay as x to the 6. This 6 combination 1, we want to figure out what that is. So we're going to go 6c1. So 6 math PRB 1, we get 6. Okay, so we have 6. And I probably need a little more room than I gave myself. So, oh, this is giving me difficulty here. What keeps doing that? Okay, so I'm going to take this. This is going to be 6. And then this is x to the 5th. And then a 5. And then I'm going to do the multiplication because it's 6 times x to the 5th times 5. So 6 times 5 is 30. So it's going to be a 30 x to the 5th. That's going to be my second term. And it's positive. Okay, now I have 6c2, which let's see what that is going to be. So 6 math, PRB, and CR2. You're going to be 15. You're going to have 15 x to the 6 minus 2, so x to the 4th, and then 5 squared, 25. So do the multiplication of 15 times 25. That's going to give you 375. So 375 x to the 4th is your next term. Okay, then you have 6c3. So 6 math, PRB, and CR3. That gives us 20. And then x to the 6 minus 3, that's x cubed. And then 5 cubed is 125. So then we do 20 times 125. And that gives us 2,500. So our next term is 2,500 x cubed. Okay, and then we go 6C4. So 6 math, PRB, NCR4. So 15. And then what is 5 to the 4th? 625. All right, so 15 x squared, 6 minus 4, and then 5 to the 4th, 625. So 15 times 625 gives us 9,375. So next term, 9,375 x squared. And we got 6 choose 5. So 6 math, NCR5, 6. So you have 6. X to the 6 minus 5 is just x to the first. 5 to the 5th. Very big number, I'm sure. 3,125. And then we multiply that by 6. So 18,750 x. And then the last term, you have 626, which should be 1. So 1 times x to the 6 minus 6, which is x to the 0, which is also 1. 1 times 1 times 5 to the 6. So 15,625. So then we're going to write out the whole answer. So you start out here, you got x to the 6 plus 30 x to the 5th plus 375 x to the 4th plus 2,500 x cubed plus 9,375 x squared plus 18,750x plus 15,625. So it's long, but this is actually a shortcut from actually having to multiply the whole thing out. Okay, and I have one more shortcut to show you to do this to make it a little bit easier. Okay. Does anybody still need that? All right, so we're going to expand this one, but we're going to do it using Pascal's triangle. So go back up here to Pascal's triangle, or this blank here, and let me show you what that is. All right, so Pascal's triangle is pretty easy to write out when you need it, but definitely keep a copy handy when you're going through your homework. So it starts like this. So you have 1, that's your first row, so that's row 0. Then you're going to expand the 1 to the side. So there's always going to be a 1 on both sides. Okay, then you're going to expand it even more with 1s on either side here. But now you're going to add the above terms. Okay, so here you're going to do 1 plus 1. You're going to put in the middle 2. Okay, then we're going to expand it again. And then I'm going to add the above terms. So I'm going to go 1 plus 2, kind of like this. And we put that here, 3. And 2 plus 1, 3. So the next row is 1, 3, 3, 1. And then I'm going to keep going, expanding again. So I'm going to do 1 plus 3, that's going to be 4. 3 plus 3, that's going to be 6. 3 plus 1, that's going to be 4. And then you just keep following that pattern. So we'll go down to 9, so you have a key. Okay, 1 plus 4 is going to be 5. 4 plus 6 10. 6 plus 4, 10. 4 plus 1, 5. That one is a little bit off. Okay, expand again. 1 plus 5 will give us 6. 5 plus 10, 15. 10 plus 10, 20. 10 plus 5, 15. 5 plus 1, 6. That's the row we just used. So it's giving you those coefficients instead of having to do the NCR every time. Okay, and then expand again. 1 plus 6 will give us 7. 6 plus 15 will give us 21. 15 plus 20 will give us 35. 20 plus 15, 35. 15 plus 6, 21. 6 plus 1, 7. 2 more. 1 plus 7 will give us 8. 7 plus 21, 28. 21 plus 35, 56. 35 plus 35, 70. 56. 28, 8. And then last row. 1 plus 8, 9. 8 plus 28, 36. 28 plus 56, 84. 56 plus 70, 126. 70 plus 56, 126. 56 plus 28, 84. 28 plus 8, 36. And 8 plus 1, 9. So that, I don't think I gave you any more higher than that, unless I'm looking for a specific term, in which case there's another formula. So you can tell what row it is just by the first after the 1 coefficient, or this is row 0, row 1, 2, 3, 4, 5, 6, etc. So it starts with row 0, not with row 1, and then goes forward. So this goes out to 9, or it's just row 3, 4, 5, 6, 7, 8, 9. Okay, so what we want to do here is a shortcut to solving these problems. So this one, we are going to expand to the 7th. So we're going to write down our 7th row of Pascal's triangle. So I got to look it up on another screen so I can grab it. Okay, so that is the 7th row. Is that the one you guys, 1, 7, 21, 35? Got that? Okay, so write down that row. Okay, so that's the row we're going to use. So then what I want you to do is I want you to take each of your terms, and we're going to write those out. So we're going to start with, we can do it all at the same time. So you got the 1, and then you're going to have your x term, which is 2x, and then your second term, which is -3. Just leave it there for right now. Then you have 7, and you have 2x, -3. So we're just taking each term and writing it with our coefficients in front. And you have 21, you've got your 2x, your first term, -3, your second term. Then 35, and 2x, -3, 35, then 2x, -3 again, then 21, 2x, -3, then 7, 2x, -3, and then finally 1, 2x, -3. Okay, you should have 1, 2, 3, 4, 5, 6, 7, 8 terms. Make sure you have 8. Okay, then you're going to put your exponents on it. Okay, so start with your first term. So your first term will start with the degree. So 7, and then you're just going to descend from there. So 7, 6, 5, 4, 3, 2, 1, 0. You have the right terms out, it should end in 0. Okay, then go to your second term, start with 0, and count up. So 0, 1, 2, 3, 4, 5, 6, 7. Okay, so once you get that set up, then you can go through and you can multiply. Okay, so this is 1 times, now when there's more than one term here, you do have to distribute that exponent. This is 1 times 2 to the 7th times x to the 7th times 3 to the 0, which is 1. Okay, so 2 to the 7th is, I don't know off the top of my head, 128. So this is 128 x to the 7th. Okay, then this is 7 times 2 to the 6th, x to the 6th, times negative 3 to the first. Okay, so you can go through, you can do 2 to the 6th, or you could just go 7 times 2 to the 6th times negative 3. So negative 1,344. And then x to the 6th. Then you got 21 times 2 to the 5th, x to the 5th, times negative 3 squared. So 21 times 2 to the 5th times negative 3 squared would be positive 9. That's going to give us a positive 6,048 x to the 5th. Then we got 35 times 2 to the 4th, x to the 4th, negative 3 cubed. So 35 times 2 to the 4th times negative 3 cubed. So negative 15,120. And then x to the 4th. And then we got 35 times 2 cubed times x cubed, negative 3 to the 4th. So 35 times 2 cubed, I think 2 cubed is 8, times negative 3 to the 4th. That should be a positive because we're going to an even. So 22,680 x cubed. Then next term, you got 21 times 2 squared, x squared, negative 3 to the 5th. Okay, so 21 times 4 times negative 3 to the 5th. So negative 20,412. And then x squared. Then you got 7 times 2 to the 1st, x to the 1st, so 2x times negative 3 to the 6th. So 7 times 2 times negative 3 to the 6th. $10,206. X. And then 1 times negative 3 to the 7th. It's just going to be negative 3 to the 7th. So negative 2,187. So there you go. So that's the shortcut, shortest way to do it. Notice that when the sign in the middle of the binomial is negative, it's going to switch positive to negative every time. So if you wanted to save time with entering into your calculator with a negative, you could just use a 3 and then just switch the signs every time. That's up to you guys. Okay. So let's say you have something really long like this. Find the 4th term in an expansion of 10, or the 15th term in an expansion of 21. I don't expect you to do the entire thing and then count it out. So there's actually a formula to find just a specific term in an expansion. So here's that formula. So you're going to go n and then r minus 1, and then x to the, so x meaning the first term, to the n minus r minus 1, and then y meaning the second term to the r minus 1. So for example, find the 4th term of a to the 2b, or sorry, plus 2b to the 10. So in this, okay, this is your r, so your n is 10. You are finding the 4th term, your rth term, so r is your 4. And then your x is a, and your y is going to be 2b. Okay, so if we follow that formula, you have 10, and then 4 minus 1, and then you have x, which is a, to the 10 minus 4 minus 1, and then you have your y, which is 2b. Since there's more than one term, I'm going to put it in parentheses, to the 4 minus 1. Okay, so that's going to be 10c3, or actually, let's just go ahead and write it like this. So 10 and 3, and then that's a to the 10 minus 3, so a to the 7, and 2b cubed. So let's see what 10c3 is. So it's going to be 120. And then you have a to the 7, and then you have 2 cubed, b cubed. So the coefficients you'll multiply out 120 times 2 cubed, which will give you 960. And then your variables are going to be a to the 7, b cubed. So we can follow that also here. So find the 15th term in the expansion x minus y to the 21st. So there your n would be 21. Your r would be 15. Your x would be x and your y would be y. Follow that. So you have, let's see, 21. And then r minus 1 is going to be 14. And then you have your x to the 21 minus 14, so 7. I'll just write it out for you guys. And then your y, do negative y, so you know which, if it's going to be positive or negative here. And that's going to be to the r minus 1, so 14. So it's even there, so that should be a positive term. So then 21c14. So 116,280. And then x to the 21 minus 14 is x to the 7th. Negative y to the 14th is going to be a positive y to the 14th. So if that were like to the 15th, then you take the negative sign, flip it to the right. Okay, so I think you got a couple practice problems here. So go ahead and do these 3 practice problems, and then we'll go over them.